Hello students, myself Hanish Bansal. Today in this video lecture we will discuss some types of matrices in which we will discuss about symmetric and skew symmetric matrix. In the previous video lecture we have discussed basis of matrix, addition, subtraction, multiplication and transpose of a matrix. On the basis of transpose of a matrix, a square matrix can be divided in two parts, symmetric and skew symmetric. First of all, we will discuss symmetric matrix. Now let's start about symmetric matrix. First of all, A is square matrix. It is very most important that for symmetric and skew symmetric, matrix will be square. For symmetric and skew symmetric, जो matrix है वो must be square. In transpose, if we want to transpose of a matrix, then it is not affected that matrix is square or any order. But in symmetric and skew symmetric matrix, it must be that matrix will be square matrix. If A is square matrix and और क्या हो A transpose is equal to A, mean A square matrix है, उसका ट्रांसपोज फाइंड किया. ट्रांसपोज कैसे? बाय इंटरचेंजिंग रो एंड कॉलम्स ऑफ ए मैट्रिक्स. ट्रांसपोज फाइंड किया और वापस वही मैट्रिक्स आ गई. देन A is symmetric matrix. If A is square matrix, it is the most important condition for symmetric and skew symmetrics that matrix must be square. If A is a square matrix and transpose of A is equal to A, then A is a symmetric matrix. If the transpose of a square matrix is equal to matrix itself, then the matrix is called symmetric matrix. For example, that we have a matrix A B, C, F, G or H. It is a matrix of 3 order 3. The order of matrix is 3 order 3. It means that A is a square matrix. We find A transpose. Transpose of any matrix is obtained by interchanging the row and columns. Transpose of any matrix, transpose of any order of matrix will obtain by interchanging the row and column. First row, change in first column. Second row, change in second column. Third row, change in third column. It is the transpose of A. By this, with that, A transpose is equal to A. A transpose is equal to A and A is a square matrix. So we can say that A is a symmetric matrix. So it is the definition of a symmetric matrix. If the transpose of a square matrix is equal to itself, then it is called a symmetric matrix. Similarly, skew symmetric. Starting that, if A is a square matrix, it is the most important and must be condition that A is a square matrix and transpose of A is equal to minus A. Transpose of A is equal to minus A. It means that we can also say that minus 1 multiplied by A. In the previous video lecture, we have discussed that if a matrix of any order multiplied by a scalar quantity, it means that all the elements of matrix multiply by this scalar quantity. Mean example that A is a matrix A, B, C, D, E, F of 2 order 3. 2 row 3 column. and we want to find clay A. Then clay A is equal to clay A, clay B, clay E, clay C, clay D or clay F. All the entries will multiply by these scalar quantities. If A is a square matrix and the transpose of a square matrix is equal to the negative of matrix, then it is called A is skew symmetric. For example, that A is a matrix. A is a matrix of 2 order 2, mean A is a square matrix. It is the must condition of for symmetric and skew symmetric, then matrix will be square. Now we find a transpose. Transpose of any order of matrix is obtained by interchanging the row and columns. First row, it is the first row change into first column. It is the second row change into second column. It is not equal to A, but if we take common minus, then we obtain 0. Minus is common, plus 2, minus common, minus 2, 0. A transpose is equal to minus, it is equal to A. A transpose is equal to minus A, and A is a square matrix, so we can say that A is a skew symmetric matrix. So there are two types, symmetric and skew symmetric. If the transpose of a square matrix is equal to itself, then it is called a symmetric matrix. And if the transpose of a square matrix is equal to negative of matrix, then it is called skew symmetric matrix. Now we will discuss some important properties of symmetric and skew symmetrics. So students, write down. हाँ तो स्टूडेंट्स, our next topic is properties of symmetric and skew symmetric matrix. Properties start. If A is a square matrix, it is given that A is a square matrix. If A is a square matrix, then first of all that A plus A transpose is always symmetric. A minus A transpose is always skew symmetric. A transpose and A transpose A is always symmetric. First of all, we will discuss about these properties. That it is given that A is a square matrix. A is a square matrix. It is given if A be any square matrix, then A plus A transpose, A plus transpose of its A is always symmetric. A minus A transpose is always skew symmetric, and A transpose and A transpose A is always symmetric. Remark here, AB is not equal to BA. The product of matrix does not obey the law of commutative. AB is not equal to BA. If the product of two matrices A and B is possible and BA is also possible, that it is not possible that AB is equal to BA. Product of matrix, two matrices does not follow commutative law necessarily. It is not compulsory that AB is equal to BA, AB is not equal to BA. It is depend upon the condition of A and B. In normally we can say that AB is not equal to BA. AB may be equal to BA, but when we apply some condition. But normally we can say that AB is not equal to BA. First of all, we prove first part. A square matrix. It is given that A is a square matrix, and we want to prove that A plus A transpose is symmetric. Now we have to prove that A plus A transpose is symmetric. is equal to A is a matrix, square matrix. A is a square matrix. Let of order n cross n. A is a square matrix. Let of order n cross n. 1 cross 1, 2 cross 2, 3 cross 3, 4 cross 4. A transpose of A. Transpose of a square matrix is also a square matrix of same order n cross n. The addition of two matrices is possible when both the order are same. So A plus A transpose is possible, and it is a matrix. Let B. Suppose that denoted by B. Let कर लिए तो इसको B से denote करते हैं. Now we have to prove that B is symmetric. If B is symmetric, then A plus A transpose is also symmetric. It means that we have to prove that B is symmetric. B is symmetric. When B will be symmetric? What is the condition of symmetric? What is the condition of symmetric? When will B is symmetric? When B transpose is equal to B. B transpose is equal to B, then B is symmetric. Otherwise not. B यदि B का जो ट्रांसपोज है वो B इक्वल हो जाए, then तो ये सिमेट्रिक है. और B ट्रांसपोज इज इक्वल टू माइनस B हो जाए, then इसको सिमेट्रिक है. अदरवाइज कुछ भी नहीं है. तो नाउ I found B transpose by putting the value of B. B is A plus A transpose. It is the value of B. A plus A transpose. Now here I use the property A plus B transpose या minus A transpose plus B transpose. Using the property of transpose, A plus B transpose is A transpose plus B transpose. B transpose is A transpose plus A transpose of transpose. Now here we use property that A transpose of transpose is equal to again B transpose is equal to A transpose plus transpose of A is A. Here we use again a property that A plus B is equal to B plus A. B transpose is equal to A plus A transpose, or A plus A transpose is B. Now we have proved that B transpose is equal to B. It means that so B mean A plus A transpose. Always symmetric. A plus A transpose is always symmetric. Second, first have proved second A minus A transpose. Given is that A is a square matrix. A is a square matrix. Now we want to prove that A minus A transpose is always skew symmetric. A minus A transpose. A is same square matrix of order n cross n. Then A transpose is also a square matrix of order n cross n. Is equal to resultant is also a matrix. Let. It means that if we want to prove that A minus A transpose is skew symmetric, we have to prove that A minus A transpose mean B. B is skew symmetric. Now we have to prove that B is a skew symmetric matrix. Or what is the definition of skew symmetric? If we want to prove B is skew symmetric, then we have to prove that B transpose is equal to minus B. We have to prove that B transpose is equal to minus B. Now let's start B transpose. By putting the value of B, A minus A transpose. By using the same law, A minus B transpose. A transpose minus A transpose of transpose. By using the same law, A transpose. Same law, transpose of A is A. Now here we use that A minus B is not equal to B minus A, but A minus B is equal to B minus A in negative. So by taking the negatives common, this A will be positive and negative. So B transpose is equal to minus B. So B is skew symmetric. So B mean A minus A transpose is skew symmetric. So mean that if A is a skew matrix, then A plus A transpose is always symmetric. A minus A transpose is always skew symmetric. Similarly, by using this, we can also prove that A transpose is always symmetric and A transpose A is always symmetric. These are two parts. A transpose is a symmetric matrix, and further A transpose A, it is the different part of this. A transpose is symmetric. This third part, and fourth is that A transpose A is symmetric matrix. Write down, then we will discuss further properties of symmetric and skew symmetric. हाँ तो students, discuss next property that all elements of principal diagonal in a skew symmetric matrix is always 0. Now let's discuss that all elements, सारे elements इसलिए of principal diagonal के इसमें in a skew symmetric matrix, it is clear that if matrix is skew symmetric, then it is also clear that matrix is a square matrix. स्क्यू सिमेट्रिक है तो स्क्वायर तो जरूरी है ना, और स्क्वायर है तो प्रिंसिपल डायगोनल होगा. तो इन ए स्क्यू सिमेट्रिक मैट्रिक्स all the elements of principal diagonal is always 0. It means that कहना जा रहा है if we have a skew symmetric matrix which skew symmetric, then all elements on the principal diagonals are 0. We have discussed this example in this video that it is a skew symmetric matrix. A skew matrix is a skew symmetric. It is a skew symmetric, so all the elements of principal diagonal is 0. Now proof. First of all, it is given that A is skew symmetric matrix. A is skew symmetric matrix. It means that A transpose is equal to minus A. It is a condition of skew symmetric matrix, and A is a square matrix. It is the most important condition for symmetric and skew symmetrics, that matrix will be square. A is skew symmetric matrix, then A transpose is equal to minus A. Minus A represented in the form of elements, that A I j of order n cross n, maybe any order, square है 1 cross 1, 2 cross 2, 3 cross 3. Then these are the elements of A11, A22, A33, A12, A13, A21, Aij. Then in transpose of a matrix obtained by interchanging the row and column. So A is Aij, then transpose Aji. Interchanging the row and it show the number of row and it show the column. Changing row and column. Order will n cross n. For elements of principal diagonal, we have discussed about the elements of principal diagonal. हमें सिर्फ principal diagonals के element के बारे में डिस्कस करना है. और for element of principal diagonals के element में विशेष प्रॉपर्टी होती है, ये डिस्कस कर चुके हैं. क्या I is equal to j, mean it means that ai elements of diagonal, principal diagonal, elements of principal diagonal are denoted by ai. I is equal to j, a11, a22, a33, a44, a55, a66. That means that I is equal to j. I is equal to j. तो J इज इक्वल टू माइनस I और J इज इक्वल टू I, बोथ आर द सेम, 2AI 0 और AI 0. So it is proved that all the diagonal elements are 0. A11, A22, A33, A44, A55, A66 all are 0. So it is proved that all the elements of principal diagonals in a skew symmetric matrix are always 0. Next property is, what is the next property? That it is the most important property. Remark, it is a theorem that every square matrix can be expressed as a sum of symmetric and skew symmetric matrix uniquely. So let's discuss about this theorem that every square matrix, it means that every square matrix, most important condition is matrix is square. Every square matrix can be, A is a square matrix, every square matrix can be expressed let's say as a sum of symmetric matrix and skew symmetric matrix. Every square matrix, कोई भी स्क्वायर मैट्रिक्स है, कैन बी एक्सप्रेस, उसे हम एक्सप्रेस कर सकते हैं, रिप्रेजेंट कर सकते हैं एज ए सम के रूप में, सम के रूप में ऑफ सिमेट्रिक एंड स्क्यू सिमेट्रिक मैट्रिक्स. मीन इफ वी हैव स्क्वायर मैट्रिक्स, हमारे पास कोई भी स्क्वायर मैट्रिक्स है, तो हम इसे दो मैट्रिक्स के टोटल के रूप में, सम के रूप में लिख सकते हैं. उसमें से एक सिमेट्रिक होगी और एक स्क्यू सिमेट्रिक होगी. भी हमारे पास एक स्क्वायर मैट्रिक्स है और हम इसे दो मैट्रिक्स के सम के रूप में रिप्रेजेंट कर सकते हैं, जिसमें एक सिमेट्रिक होगी और एक क्या होगी, स्क्यू सिमेट्रिक्स. और मोस्ट इंपॉर्टेंट दैट यूनिटली, मतलब एक ही फॉर्मूला होगा, एक ही तरीका होगा. मतलब एक स्क्वायर मैट्रिक्स के लिए मीन हमारे पास कोई भी स्क्वायर मैट्रिक्स है, यदि हम उसके लिए टोटल बनाते हैं, ये वे बनाते हैं, हमारे पास एक ही वे होगा और कोई वे से हम इसको रिप्रेजेंट नहीं कर सकते. अब इसको प्रूफ करेंगे इन शॉर्ट ही, ज़्यादा लॉन्ग में नहीं करेंगे, इन शॉर्ट ही प्रूफ करेंगे अपने. इन शॉर्ट प्रूफ कैसे करते हैं अपने कि अपने तो क्या प्रूफ करना है कि अपने पास एक स्क्वायर मैट्रिक्स है, ए इज ए स्क्वायर मैट्रिक्स, और अपने उस स्क्वायर मैट्रिक्स को दो मैट्रिक्स के सम के रूप में रिप्रेजेंट करना है, जिसमें से एक स्क्वायर होगी, सिमेट्रिक होगी और एक स्क्यू सिमेट्रिक होगी. देखते हैं, जैसे अपने पास ए स्क्वायर मैट्रिक्स है, इसको मैं दो मैट्रिक्स के सम के रूप में रिप्रेजेंट करूँगा, जिसमें से एक सिमेट्रिक होगी और एक क्या होगी, स्क्यू सिमेट्रिक. लेट्स स्टार्ट. A is a square matrix. Now we can say that A plus A transpose is always symmetric. We have proved in this video that if A is a square matrix, then A plus A transpose is always symmetric and A minus A transpose is always skew symmetric. In this video, we have proved that if A is a square matrix, then A plus A transpose is always symmetric and A minus A transpose is always skew symmetric. If A plus A transpose is symmetric, then if A symmetric and skew symmetric matrix multiply a scalar quantity does not affect, then half A plus A transpose. A plus A transpose is always symmetric. If this symmetric matrix is multiplied by any scalar quantity, 1 by 2, 1 by 3, 2, 4, 3, then it will remain same, that symmetric. प्रॉपर्टी सेम, वैल्यू चेंज हो जाएगी, मैट्रिक्स की वैल्यू चेंज होगी क्योंकि मल्टीप्लाई बाय 1 by 2 होगा, बट रहेगी वो सिमेट्रिक. और सिमिलरली हाफ A माइनस A ट्रांसपोज इज ऑलवेज skew symmetric. mean A is skew matrix है, then we have proved that A plus A transpose is always symmetric, A minus A transpose is always skew symmetric. If a symmetric and skew symmetric matrix multiply by any scalar quantity, then symmetric will remain symmetric and skew symmetric will remain skew symmetric. Mean A plus A transpose symmetric है. यदि इसको किसी भी स्केलर से मल्टीप्लाई कर दें 1/2, 1/3, 1/4, 2, 3, 4 तो ये सिमेट्रिक रहने वाली है. ठीक है. Now by adding these two, half A plus A transpose, half A minus A transpose, it is symmetric or it is skew symmetric. Or total of these matrices, half A plus half A is A, half A transpose minus half A transpose. Mean that we can say that 1/2 multiply A plus 1/2 multiply A transpose plus 1/2 multiply A minus 1/2 multiply A transpose. These are cancelled. 1/2 A plus 1/2 A is A, or A is a skew matrix. So skew matrix can be represented as sum of symmetric and skew symmetric. It is the formula of representing a skew matrix as a sum of symmetric and skew symmetric matrix, in which A plus A transpose half show symmetric matrix and A minus A transpose half show skew symmetric matrix. So it is proved that every skew matrix can be expressed as a sum of symmetric and skew symmetric matrix uniquely. Uniquely mean that it is a single way of representing. Here no other way of representing the skew matrix in the sum of symmetric and skew matrix. Here a single formula and a single way, no other way to representing the skew matrix in the sum of symmetric and skew symmetric. ठीक है. It is proved A is a skew matrix, then A plus A transpose is always symmetric, A minus A transpose is always skew symmetric. It has proved in this video. If a symmetric matrix multiply by any scalar quantity, then it will remain symmetric. Or if a skew symmetric matrix is multiplied by any scalar quantity, that it will mean skew symmetric. By adding these two, with that is equal to A. So every scalar matrix can be represented as a sum of symmetric and skew symmetric matrix by using this way. So it has proved. Write down. Then we will discuss about an example on the basis of this theorem. हाँ तो स्टूडेंट्स, now let's discuss example. A is a matrix 6, 2, 5, 4. We can see that the order of A is 2 cross 2. It means that A is a square matrix. इसे एक्सप्रेस करना है एज ए सम टोटल के रूप में, इसलिए सिमेट्रिक एंड स्क्यू सिमेट्रिक. सॉल्यूशन. We have discussed the theorem that a matrix of square matrix can be expressed as a sum of symmetric and skew symmetric by using the formula that A is equal to half A plus A transpose or half A minus A transpose. It is symmetric and it is skew symmetric. Now let's start. First of all, we have required A is given, required A transpose. So let's find A transpose. Transpose of a matrix obtained by interchanging the row and column. First row is 6, 2, change in column. Second row 5, 4, change in column. It is A transpose. Now find A plus A transpose. A is 6, 2, 5, 4 plus B is 6, 2, 5, 4. 6 plus 6 is 12. 2 plus 5 is 7. 5 plus 2 is 7. 4 plus 4 is 8. Then half multiply by A plus A transpose. Multiply by half, 12 by half, 6. 7 multiply by 1/2. 7 multiply by 1/2 is 7/2. 8 multiply by 1/2 is 4. It is half A plus A transpose. Now we will find A minus A transpose. A is 6, 2, 5, 4 minus A transpose is 6, 2, 5, 4. find A minus A transpose. 6 minus 6 is 0, 2 minus 5 is minus 3, 5 minus 2 is 3, 4 minus 4 is 0. It is also proved that A minus A transpose is always skew symmetric, and all the elements of principal diagonal of a skew symmetric matrix is 0. We have discussed that all elements of principal diagonal in a skew symmetric matrix is always 0. Now we have find half A minus A transpose. A minus A transpose multiplied by half, half multiply 0, 0, half multiplied by minus 3 by 2, 3 by 2, 0. Now A is equal to half A plus A transpose plus half A minus A transpose. Here it is symmetric and it is skew symmetric. Now by putting the value, half A plus A transpose is 6, 7 by 2, 7 by 2, 4, plus half A minus A transpose 0, 0, minus 3 by 2, 3 by 2. It is symmetric or it is skew symmetric, or A is square matrix. So it has proved that square matrix is represented as a sum of symmetric and skew symmetric matrix. Square matrix is a sum of symmetric and skew symmetric. इन दोनों को ऐड मत कर देना, ऐड करने पर तो ये वापस क्या बन जाएगा, ए बन जाएगा. हमें ऐड नहीं करना, तो हमें सिर्फ करना है सम के रूप में ही एक्सप्रेस करके बताना है उसको, टोटल के रूप में बताना है. तो सम के रूप में एक्सप्रेस करके बताया है सिमेट्रिक और स्क्यू सिमेट्रिक. ऐड कर दो ले तो वापस ए बन जाएगा. 6 प्लस 0 6, 7 by 2 minus 3 by 2, 4 by 2, 4 by 2 2, 7 by 2 plus 3 by 2, 10 by 2 is equal to 5. 4 plus 0 is 40. तो ये बन जाएगा, वो तो ए बन रहा है, बट हमें तो सिर्फ सम के रूप में ही एक्सप्रेस करना है. ये अपना मैट्रिक्स का जो चैप्टर था वो कंप्लीट हो चुका है. मोस्ट ऑफ क्वेश्चन इसलिए आप कर सकते हो. और आई होप कि आपको जितना भी इस वीडियो में या इससे पहले वाले 2 वीडियो में समझाया गया है वो आपको मैट्रिक्स पूरा समझ में आ चुका होगा. ठीक है, और इससे अपना मैट्रिक्स वाला चैप्टर कंप्लीट हो जाएगा. इन द नेक्स्ट वीडियो लेक्चर वी विल डिस्कस फर्दर दैट डिटर्मिनेंट इनवर्स ऑफ ए मैट्रिक्स, एप्लीकेशन ऑफ डिटर्मिनेंट्स, डिटर्मिनेंट इनवर्स ऑफ ए मैट्रिक्स, एप्लीकेशन ऑफ डिटर्मिनेंट्स. So if you liked the video, then please like and share the video and subscribe my channel. Goodbye students.